So thank you very much for accepting that I changed my topic. I applied first for an update of the PERAMIS project. I presented in the last IMC briefly because it was the Perseids observation of 2022. But unfortunately, I discovered some systematic errors in the analysis, and so I have to leave this behind and find a new way to deal with these data. I hope still that they are worthwhil. But I will give you a short speech about an observation that I made together with Bernd this year's Perseids. And the question for me was exactly, thank you, Detlef, that you described it so colorfully. Was that an impact of a meteoroid that I have just seen with my bare eyes? So a very strange thing. I'm not the visual type. You know that I'm like video observations most of the time. And I also made tried some video observations of moon impact, meteoroid impacts. You see my first attempt here in the 2017 quadrantites. With a very small telescope. It's just a 10-centimeter refractor, but I did some kind of bric-a-brac to avoid stray light and to improve the contrast of the image. This was the first attempt, and the second one was during the ETA Aquaries together with Bernd with improved technology from the recording side, but the same telescope. So Bernd and I went to the Perseids observation to Austria. There's a famous valley called Ötztal, and at the end of the valley is a city, this village called Sölden, and above that, another 17 kilometers on a street you can go to this place on the Tiefenbach Glacier, or the remnants of the Tiefenbach Glacier. And it's nearly 3,000 meters altitude. And I think in 2021, we were really above 3,000 meters with the car. You don't get that so often in Europe that you can go up with car in more than 3,000 meters. Good observing site. What you see, this image was made by Bernd. You can see the author always here. And you see not so much of my equipment, but Bernd setting up his 6-inch Newtonian for the observation of moon impacts. But not me. I was looking for the Perseids itself with my, I call it the quad, for Sony Alpha 7S with external recorders, as you see here. But I also had a very classic DSLR running with a timer, making photos every 13 seconds. And when shortly after the moon came up above the Alpine mountains, was a very beautiful sight. We had some little veils of clouds there, so the moon was not that bright, so you could see very, very nicely the two horns coming up above the mountains. And of course, first you could see the dark side of the moon. And I was entirely focused on the moon. And then Bernd is my witness. I said, oops, what was that? And at that time, the moon was just 1.5 degrees above horizon. And on the dark side of the moon, I had the impression that I saw exactly what Detlef described just in the presentation before. So this was on 0, 50 minutes and 5 seconds UT. And now you can see the stars here. Of course, this is Capella. This is Auriga. By the way, there's a meteor also, but that's not the main figure. Here you cannot see the dark side of the moon because of the overexposure of this image. But I thought that it was comparably bright as Beta Auriga here. And it was very much down to the horizon, so I could give another magnitude for the extinction. That was my first estimate. So I ran to the radio clock and made this remark here. And made a highly scientific sketch. Yeah, but I think Galileo's sketches were also not very elaborated. But so this was what I saw. So my first estimation was 1 magnitude because Beta Auriga has 2 magnitudes, so give 1 for the extinction. Later, I thought, well, you have a lot of stray light and blinding effect by the bright side of the moon, so give another magnitude and correct it for 1 meg, for 0 meg overall. So, and encouraged by discussion with others, I sent this note to Tony Cook. Detlef introduced him in his presentation, and that had this very, very short-term flash on the dark side of the moon at approximately this position at that time. Unfortunately, the moon was very, very down, so not many European observers had already set up their telescopes for this. And but after all, I decided to keep my trap shut or to make a report before, but not to come up if someone, if Neil Yotta mentions that there was an impact and said, oh, I said it with my bare eyes. That was the wrong direction, I think. So could I have observed a moon impact? Is that possible? And of course, the best witness would have been Neil Yotta, but I'm not quite sure if this position is inside the field of view of this telescope. So maybe even if Neil Yotta had set up the telescope at that early time already and switched the cameras on, I'm not sure if they would be inside their field of view. Not good for me. But to be self-critical, what could it have been what I've seen? Of course, when you say, well, Peter saw Sternchen, yes, this is one possibility, but as scientists, we want to cover all possible physical reasons. So what could it be? It could be in the eye of the observer. I step aside and this guy has observed something, and it could be an effect inside his eye. This could be simply a visual malfunction. Yes. We all have sometimes visual malfunction. Seeing Sternchen is a visual malfunction, but it is seeing. It's not something that you just imagine. It is that you see something. Another thing is cosmic. A cosmic can not only hit silicon, but also hit our retina. So what would be the effect if a cosmic particle hits the cone cell of the retina of the observer? Here's some nice collection of cosmics that hit silicon, the silicon of my cameras, but it could also happen to hit the retina. So then comes the space between the observer and the surface of the moon, because I saw it on the dark side of the moon, so the space in between can be also, there can also be some reasons. Could be an aircraft. They have different lights, they have position lights, they have searchlights, and it could be also if reflecting a satellite. By the way, this might be a favorite reflecting a satellite, but we will see it's not so easy. It could also have natural origin, electric discharges in the atmosphere. So, for example, lightning. We had some bad weather at that time, especially on the second night, but in the first night, there was also some lightnings around, but not at that direction. Well, you never know. And of course, it could also have been a meteor that comes straight ahead to the eye of the observer, so it's exactly in the radiant. But it's a question if a meteor has such a brightness profile, and I think it would not be that short-termed. And of course, on the surface of the moon, many things can happen. A natural meteoroid impact is just one opportunity, but it could also be a satellite falling down onto the moon. And that's exactly what we experienced 1 week afterwards. It was not Luna 25, on that date, it was 1 week later. And the question is also if there are some natural kind of energy or explosions on the moon that could light up that bright. Or now, conspiracy theory, some atomic testing on the dark side of the moon or something like that. But you cannot exclude on the first hand. And maybe I forgot something. Please give me your advice. So here a cross section, by the way, this is from the introductory script of the first semester. We have the retina with this cones and rods in the fovea. We have many of the cones. So the smaller ones that are not that light sensitive but have a higher resolution. And well, it could happen that some particle hits one of or some of these cones, and there must be some kind of excitement. And what does the visual system do with this? Well, I made a test with my cameras I had presented on an earlier IMC, and I experienced in a full frame camera sensor of that size approximately 10 or 5 to 10 particles per minute. So if this would be seen, we would all would see cosmics all over the time. Nature is very clever, and I think it would have prevented us from this. So why wouldn't we not see cosmics very often? Well, the visual system doesn't consist only from the retina, but also from the nerve and, of course, from the brain. And when you see that the nerve has 100,000 fibers, but we have 130 million of cones and rods, so there's huge amount of data compression, you would call it, more than 1 to 1,000. And so the intelligence in this data compression might suppress cosmics because they are not useful for us to detect as human beings. So I'm not very convinced about this. Okay, then Bernard had his telescope later on, had his telescope ready, not at that time, unfortunately. And he recorded, thank you, he recorded this. Where's play? I'm sorry, where's play? Play the video? Ah, yeah, fine. Okay, play it again. So you saw the blinking. That was position light. But in fact, I was fully focused on the moon. If the aircraft has been there, I should have been seeing the aircraft because it was going over the moon, also over the, or maybe also over the bright side. And this position light, they are have a certain frequency, so I would not have seen it only once. Maybe more probably it was the searchlight when the aircraft is landing and directing the searchlight to the observer. It can be very, very bright and even more than 1 magnitude. But then the brightness profile would be longer. It would not be a single flash. It would be longer to move the aircraft to my direction and then go a little bit further. Does not look as what I've seen, probably. So that was the aircraft. A little later, Bernd also recorded this. One of, what was it? Starlink, okay, yeah, our darling, yeah, our darlings. So this is a constantly illuminated satellite with a transversal movement, but could it, pardon? 5 minutes, yeah, okay. But could it not be that it is just a reflection of a rotating satellite? That would be more probable for me. And then you have to look at the angles. The moon was 1 degree and 1.5 degree above horizon, and it had an angle of 36.3 degrees to the sun. So that must be a satellite that is quite far behind the horizon to be able to reflect directly the sunlight to my direction. But that would give an effect as it was observed. Yeah, the question of human-made impact, I have to rise. Or, well, this is my candidate, or suspicious impact I recorded once, but that's still an open question. So, wait a minute, we have a photo. Can we see something from out of the photo? Unfortunately not, because wide-angle lens. And I did some photoshopping here, but you cannot see anything here because the exposure time of 13 seconds of the photo was far too long for the very, very short flash to be visible here. So no, unfortunately. And even if it would, I'm sorry, it would not have been a Perseid. So now, please help me. What did Peter see? If you say nothing, okay, I will never hold a speech like this anymore, I see. But I would really like to see your scientific view. And now I give this voting to our president of the conference, Hervé. Where are you? Hervé?
Hervé?
Okay, so he is my witness. It's closed, and I hardly invite you to make your voting and just give probability percentages. They must not end up in 100%. I made a Excel file. So this is for Hervé. This is my voting, and in the proceedings, you will, at least in the proceedings, you will see both the average of your voting and my personal voting. So don't let me be alone with this observation. Thank you. There's an image. There's no image. Okay, so this was it. So please take a little time. And even if we will have the box for collecting the votings during the coffee break, and yeah, you can think it over until the end of the coffee break. Thank you very much.
In the meantime, is there anyone else that has a question, even online, in case, while we try to settle this out?
What?
Oh, wait.
Yes.
I'll give you.
I can't answer the first one because I don't know how good your eyes are.
Yes. The question was, how good are my eyes? Well, we can make a test if you like. And we step back from where I can read something. And we put our eyes close to each other and go back. So now I can still read it. I think they are not bad. And I was fully focused on moon. That was coincidence.
Great. Thanks a lot again. Oh, sorry. My bad.
Okay. Hello, Peter.
Hello.
I have just a comment that during a lot of evaluation of metric data, we regularly found such flashes in the field of view. And with Ernő Berko, my Hungarian friend, we made simultaneous observations and calculated the position, and they turned out to be satellite flashes. So it's not a rare event. We quite often record it. Of course, the chance that this happens just in front of the moon is much lower. But
well, that's
so yeah, I would vote for meteoroid impact. Or
yeah, now you are influencing the others. But
okay.
Please, I'm very interested to have your vote.
Thanks a lot again. In case all the letters here. Oh, still one. We're kind of running out of time, but very, very short.
Yeah, is there something else that fits well to the satellite thing? There are a lot of balloons flying, and they have to have the flashlight for the ADS at a certain mass range in the night, and you would only spot a short flash because the gondola is.
Yes, but
Very
you will have
unlikely,
that in some seconds again. So I mean, they do not flash once and then stop it.
Okay.
That's the same with the aircraft's flashlights.
You need to be aligned, and the gondola is doing a random motion.
Oh, the flashlight? Okay.
We can discuss further maybe later.